Okay, question 10. Fx is a function defined for all real values of x. Which one of the following is a sufficient condition for the integral fx dx from 1 to 3 equal to 0? Okay, so a sufficient condition means that, if I have that condition, then no matter what, the statement is true, right? For example, if a was a sufficient condition, then that means that if f of 2 is 0, then the integral must be 0, right? Okay, so let's see if that's true. So when f of 2 equals 0, does the integral have to be 0? Let's see. What if I draw something like this? So let's say, so the f of 2 is 0, right? So I must pass through this point. What if I do something like this? Then the integral is clearly not 0, right? Because there's area here, right? But then f of 2 is indeed 0, yeah? So that's why a is not a sufficient condition, all right? Okay, so same logic. How about b? F of 1 equals f of 3 equals 0. Is that sufficient? So we're going to start at here and end at here. So, well, it doesn't really matter. Just maybe like this, right? Then you've got area here. Yeah? So b is also not sufficient, all right? Good. Okay, c, f of minus x equals negative fx for all x. I mean, essentially, I could just take the same same function, right? I mean, basically what c is saying is that this is an odd function, right? This is exactly the definition of the odd function. So odd function means that there's rotational symmetry about the origin, right? So if I take a function like this, like if this is minus 1, this is minus 3, and I take the same shape here, and then I don't know whatever I do here in the middle, yeah, then, well, this satisfies c, right? But then, the area between 1 and 3 is still not 0, right? I just need something which has rotational symmetry around the origin, and then I'm fine, right? So c is also no good. Yeah, c is also no good. Okay, how about d? So d actually looks like c, actually, if you have a think about it. Right. So what's the best way of thinking about it? Maybe if you think of it like this. So put the minus sign to the left-hand side instead. F of x plus 2 equals f of 2 minus x. Yeah? So the negative goes to the left-hand side. So how does this relate to c? Well, this condition, okay, or even, maybe let me make it even clearer. So this becomes 2 minus x equals negative f of x plus 2. Okay, so that's even clearer. Yeah? So what happened? What happened is that you added 2 in the brackets. You added 2 in the brackets. Yeah, in both brackets, left hand side, right hand side. Right. Okay. So after adding 2, then you get the relationship in C. Right. So that means that after you move the graph to the left by 2, then you have rotational symmetry around origin. Right? After you move the graph to the left by 2, you have rotational symmetry around origin. Yes? That means that originally, where do you start? Well, you started with rotational symmetry at the point 2, 0. Right? Because if you didn't start there, then there's no way that you move to the left by 2 and you still have rotational symmetry, right? So that means that the condition in D is what? Is rotational symmetry around 2, 0. Right? And that's exactly what you need, really, for the integral. Right? So that's exactly D. Yeah, so the answer should be D. Okay, well, let me explain why, rotational symmetry around 2, 0 gets you there. Because, imagine this is 1, 2, 3. Then, for example, if I do something like this, then you need rotational symmetry here, right? So therefore, the negative area here is the same as the positive area here. Right? That's why, at the end, it cancels to 0. Right? Okay, lastly, let's show that E is not sufficient. So technically, E is just the same as C. Because if you sub in, for example, what I want to sub in, y equals x minus 2, for example, then you get C again, right? Because that gives me f of y equals negative f of negative y. Yeah, again and again, you take the negative to the left hand side, then condition E is just the same as condition C, right? So it's not E. Good. So final answer is D.